Hi everyone, welcome back to my channel. So we have already seen what are the various types of supervised learning and what are the various types of classifiers which are available. So today in this video we'll be seeing what is naive Bayes classifier in machine learning. So let's get started. So there are two terms, that is we have naive and Bayes. So some people may call it as naive and naive, so it's upon your discretion, like what you can call it as naive or you can call it as naive. So to begin with, naive Bayes is basically a classifier which is under the supervised machine learning group, which is based on some probabilistic logic. Now what this probabilistic logic it uses is, it uses the Bayes theorem or the algorithm which are based on the Bayes theorem. It mainly uses that. So Bayes theorem is basically a form of mathematical probabilistic technique where you calculate the probabilities of an event. So it just considers a set of probabilities. Now we already know, like we have a data set and then we divide into training and test set. So the training set, we input different types of attribute sets. So in naive Bayes, what we have set of probabilities. So it can be like we have p0, p1 up till pk. So we have these many number of probabilities. So this probabilities we just input into the training set and we get a prediction as a result of that. So for each attribute from each class set, like each attribute belongs to each of this class set. So we have xi, x1, we have x1 to xn, that is each of the attribute set, and it belongs to each of the classes, that is c1 to ck. And so those classes, it makes use of the probability to make any predictions. So the data model which we get or which is yielded from this effort is called as a predictive model, which uses the probabilistic problems at foundation. So we already know, like we have the data set which has n number of rows and n number of columns. We just divide into training set and test set, which is of, like say for example 2/3 and 1/3. Then we just test, we just take the training set, and to this training set, now what we have different kinds of probabilities, and this we create to a prediction model or a predictive model, and the output what we get from this is different kinds of predictions. So this is how the naive Bayes classifier works. So the Bayes theorem, which we mainly discussed here, so it's a mathematical estimate. So what it states that probability of an event based on a prior knowledge of conditions that might be related to that event. So this can be said like you want to calculate probability of particular event given that some already prior known conditions are there. It means, for example, say for instance, like I want to go out for cycling. So probability of me going outside for cycling, given that the condition is good or the weather is good, then I will go for cycling outside. Else if it's not good, or if it's cloudy or if it's rainy outside, then I'll not go. So similar is that. So basically in human beings, the classification power and the things which we can classify is very much powerful as compared to machines. So that's why the feature extraction in human beings is so tightly coupled, is that there is less chance of us making any mistakes. So now we discuss about this term, that is naive, why it is called as naive. So there are basically two things which makes it naive. So first is the nature and second is the assumption. Now let's see what nature it has. So the nature, basically it works well on text data. Means whatever text data, like if it's a CSV file or XLS file, it mainly works on that, and it majorly emphasizes on categorical data as compared to numeric data. So categorical data, it's like marital status, that is single, married or not married. So it mainly functions on that a good amount, and it performs very less on numerical data. And the assumption it carries is that all attributes are independent of each other. It means like for a particular class we have n number of attributes. So for each attribute, this naive Bayes assumes that each of those attributes are independent, means they don't have any correlation among them. So these two reasons are mainly why it is called as a naive Bayes algorithm or a naive Bayes classifier. Now in this you need to calculate the probability. So this is how the posterior probability is calculated in naive Bayes. So this what you call, it's a posterior probability. Now you can just understand this as you need to calculate the probability of class given that you have already know the features. So it's probability of class given that already that condition has occurred. So this is the posterior probability, and this basically is the likelihood of the prior probability which you want to calculate and probability of the class which you have, and these are the probability of the other features which you calculate. So with this equation you basically calculate in naive Bayes and you implement in your algorithm. Now I have considered certain steps for the implementation of naive Bayes. So here it goes, there are 5 basic steps to implement naive Bayes. So basically in order to do naive Bayes, you first have to load your data. So that data can be anything like in .xls or .csv format, comma separated value, and then you just divide it into training set and you divide it into test set. Next is you need to prepare this data. So what you do is you just take the training set and you calculate the probabilities of the attribute values it has, probabilities of attributes, and then at step 3 you generate a forecast. So forecast means like first you just clean your data and organize it, and then you just create with the help of this training set the probabilities which you have calculated. You just try to predict the data or the labels of your test set. Next what you do is you evaluate the performance. So performance is evaluated by iterating over these steps, that is step 2, step 3 and step 4, and then the accuracy is calculated and it is tried to improve. So if accuracy is not good, you just try over these iterations again and again, and there should be least error margin in this. So that is the main goal of this evaluating the performance. And finally you do the cleanup and finalization. So that you carry out by cleaning and organizing and followed by polishing your predictive models, and finally you have the code ready, and that code you just implement in your algorithm so that any new test data which it comes, it does the classification in this format. So well, that was all regarding in this video regarding the naive Bayes. So hope you guys enjoyed this. If you found you got educated watching this video, please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.